Hi, my name is Kristen, and today I want to talk to you about how assessment in mathematics has a direct impact upon students' learning experiences. This presentation will provide an overview of assessment strategies used in mathematics, including portfolios, peer assessment, and observations. I'll also provide recommendations for record keeping and reporting whilst focusing on the number and algebra strand of the Australian curriculum. According to Reyes et al. And Churchill et al., both agree that assessment in mathematics should overall support students' learning and development, be fair, inclusive, and sensitive to a range of abilities, and inform teaching practice. The first assessment strategy I would like to discuss today are mathematics portfolios. According to Reyes et al., portfolios are purposeful collections of work which display student accomplishment and progress over time. Portfolios are a great resource for both assessment and record keeping, and can be in both physical form or digital form, such as through applications like Seesaw. Portfolios fulfill both a formative and summative function and incorporate a wide variety of data that helps students' progression over time. Assessment by portfolio is authentic, and it encourages students to develop self-reflection and autonomy, transferring responsibility for learning from the teacher to the learner accordingly. The main issue with implementing portfolios, as identified by Rosal, is that they can be very time-consuming to organise, implement, and evaluate for both students and teachers. However, in saying that, they are a great tool for recording and reporting on student progress to parents. An example of this in practice might be in a classroom where students are utilising the digital portfolio system Seesaw. In this example, students use their interactive whiteboards to solve a range of addition and subtraction problems and must show their working out to the final answer. Students then post pictures of their whiteboards onto Seesaw, which can be viewed by both parents and teachers. This activity can be catered to all students in the classroom by simply adjusting the level of difficulty in the problems accordingly to suit students' abilities. The next assessment strategy I would like to discuss is observations. Maxwell describes observations as observing students during their work and in conjunction with understanding their performance. The benefits of observations as an assessment strategy include that they can provide quick and instant feedback on students' progress, according to Weil. They also help to provide measures or records of behaviours towards mathematics in the classroom, and that they are a flexible approach to data collection in mathematics and suitable for a broad range of contexts. Weil argues that observations can lack objectivity and become inconsistent if they are not implemented correctly, especially if careful documentation is not taken at the time of observations. Observations alone are not suitable for assessing mathematical ability and should be implemented in conjunction with other assessment strategies. Checklists are a great tool for recording these observations, as they are quick and can easily be adapted to whole classroom activities or individual students. Detailed annotations on these checklists can assist with reporting purposes for teachers of their students' achievements. An example of this in practice might be in a Year 2 classroom, where students are utilising number lines to visualise number sequences to represent and solve addition and subtraction problems. By observing students as they solve problems using their number lines and recording these observations in a checklist style based on accuracy and understanding, the activities can be differentiated based on students' mathematical ability and using easier addition or subtraction problems for students who are struggling. The final assessment strategy I want to talk about today is peer assessment in mathematics. As stated by Wiley and Lyon, peer assessment provides students with the opportunity to reflect and assess the quality of others' work based on a set of criteria. Peer assessment in mathematics supports students to think metacognitively about their learning, and it engages students in the learning process and develops their capacity to reflect on and evaluate their own learning and skill development. Howe notes that it is important to recognise that peer assessment can become subjective and influenced by student bias, and therefore result in low reliability and validity. Peer assessment also requires adequate preparation and development of a clear assessment criteria. As with observations, peer assessments require detailed annotated notes by the teacher or anecdotal notes, which are written by the teacher in response to a product or performance the students have completed, as well as capture observations made during students completing their peer assessment with each other. These anecdotal notes can be used for reporting to parents later in the year. In this final example, in a classroom setting, Year 2 students have been asked to work in pairs to recognise Australian currency through matching notes and coins. Students work individually to match combinations of notes and coins whilst coming together to peer assess each other's findings and how they got their answers. This activity could be differentiated by using larger note values or more simple coins. So in summary, assessment is used in the classroom to exhibit student performance and achievement over time and to inform future teaching practices. The use of assessment strategies such as portfolios, observations, and peer assessment all have significant impact on students' learning experiences in mathematics. Thank you for your time.